Okay, so in the last video we talked about how there are 5 ways to prove if a quadrilateral is a parallelogram. And if any of these happen, that is enough information to prove that we have a parallelogram. So let's just do a quick review. If both pairs of opposite sides are parallel, then we have proven it's a parallelogram. But those markings have to be shown. If the diagonals bisect each other according to the diagram and the showing and the markings, then we know we have a parallelogram. This is the only one that was unusual. If we have one pair of opposite sides and that same pair are both congruent and parallel, then it is a parallelogram. And then number 4, if both pairs of opposite sides are congruent or both pairs of opposite angles congruent. Those are all ways that we can prove that a shape or that a quadrilateral is a parallelogram. So one part of your homework is going to have something similar to this on it, and this actually is the notes on page 73, so you can fill these in your notes. Okay. So this one, numbers 20 through 25, are going to be similar to a part of your homework as well. You're going to have a quadrilateral in here, and it's going to ask you to state whether the given information is enough to conclude that that shape is a parallelogram. So you're going to put the markings on the diagram, and then you're going to compare to these. Okay? So, there we go. Let's start with this. Angle SRW, SRW. One second, I might need to smooth that down just a little bit so you can see it. There we go. SRW, which is SRW here, is congruent to WTS, which is here. And RST, this angle, is congruent to TWR, this angle. So what they just showed us was opposite angles are congruent, and number 4 says if both pairs of opposite, number 5, if both pairs of opposite angles are congruent, then that is enough to prove that you have a parallelogram. So number 20 would be yes. Okay? All right, let's take that off. Okay. Number 21 says TSZ, smaller angle, and RSZ, side by sides, are congruent to each other. And then it says TWZ, this one, and RWZ are congruent to each other. Now, if you look closely at those, that doesn't really go with anything over here. Telling us that these two side-by-side angles are congruent is not one of them. The only one that deals with angles at all is number 5, and it says opposite angles are congruent. They are not showing that opposite angles are congruent, so my answer is going to be no. Okay, number 22. RS and WT are congruent. Those are sides. RS, WT. And, oh, I'm sorry, that wasn't congruent, that was parallel. So these sides are parallel to each other. RS is parallel to WT, and RS is congruent to WT. So we have a pair of sides that are parallel, and those same sides are congruent. That's going to be number 3. One pair of opposite sides, both congruent and parallel. So yes, that would make a parallelogram. Okay, let's do number 23. RS is parallel to WT. Draw the parallel markings. And ST is congruent to RW. So I have a pair of parallel lines and I have a pair of congruent sides, but they don't tell me, or it doesn't say that it's the same one. So it's not number 3, because it has to be the same pair that are both congruent and parallel. By themselves, this is not enough information to prove that this is a parallelogram. So the answer would be no for that one. Okay, now let's look at 24. RS is congruent to WT, and ST is congruent to RW. That should be sticking out to you as number 4. Both pairs of opposite sides are congruent. Since they're telling you that opposite sides are congruent, then yes, that would have to be a parallelogram. Okay, and then number 25, RZ is congruent to let's do one, TZ, and SZ is congruent to WZ. So look where those markings are. Those markings are located on diagonals. And number 2 says the diagonals of a parallelogram bisect each other. So if they are showing you that they are congruent on either side, then that's telling you that those two lines are indeed diagonals and they are crossing each other and they are creating equal pieces. Okay? So since the diagonals bisect each other, then yes, that would be a parallelogram. Okay? Alright, so let's go to the last 2 examples. They're slightly different from each other. This one just simply says, very similar to what we've done before, find the values for x and y for which the figure must be a parallelogram. And you can see where we have angle markings. Well, this one has an x for a variable in it, and these two have a y. So we're going to leave the x out of there for now, and we're going to find the y first, because at least I have the same variable filled in. Now the next question is, what kind of angles are A and B and M? Are they opposite angles or are they consecutive angles? Consecutive angles are angles that would add up to 180. So that's how I'm going to set this one up. I'm going to do 12y plus 8 plus 5y plus 2 equals 180. And I'm going to solve it for y. So 12y and 5y are 17y, and 8 and 2 is 10. Okay, so if I go ahead and solve that now, oops, I'm sorry. 170. So if I divide by 17, I get that y equals 10. Now that's just the value of y. I still have to find the value of x, but the only relationship I can see among these is that this x and this a are supplementary. Okay? So if we already determined that y is 10, then I can plug y in here, and then those have to be supplementary. So I could do 5 times 10 plus 2, which is going to give me 52 degrees. Okay? So the 2x and the 52 degrees are consecutive angles. So those are going to have to be, equal, 2x is going to have to be Well, actually, you know what? It would have been better for me. Let me go back. Let's plug it in for this one, because if it plugs in this one, these are going to be exactly the same. So let's plug it in here. You could have done it the other way as well. You just had a little bit more figuring to do. So this is going to be 120 plus 8. So that's going to give me 128 for angle M. Now, that means that angle P is going to be 128. But it's not just an x, it's a 2x. So I have one more equation to solve. 2x equals 128. And that means that x is going to equal 64. So again, I'm just using these to solve the problem. Now, this last one is a little tricky, because this last one not only tells you to find the value of x, but then it says, then tell whether the figure is a parallelogram, which means after I find the value of x, I'm going to have to plug x back into the things that are in the diagram and see if the definition of a parallelogram holds true. Okay? So, one thing I noticed, I have this 50 and this 2x right here. Okay? What you should recognize is that if this is a parallelogram, opposite sides are parallel, then you should be able to see that this angle and this angle are alternate interior angles. Interior because these are the parallel lines, so these lie on a transversal on opposite sides. So that would be alternate interior angles. So alternate interior angles are congruent, so that's what I'm going to do. I'm going to set 2x equal to 50. And I get x is 25. Okay? Now if x is 25, then everywhere I plug in an x, I could be able to solve or show these angle measurements. So if I plug it, obviously if it's going to be alternate interior angles, they're both going to be 50. Now let's come up here. If I plug in 25 here, I'm going to get a 40-degree angle. And if I plug in 25 here, I'm actually going to get a 90-degree angle. Now, all that said, I have to now look to see if those angle measurements would make a parallelogram. Okay? Well, clearly this one would, right? Because alternate interior angles are equal to each other. Okay? But now I'm going to have to do something with this, which is 40, and this, which is 90. Okay, so this is where it gets a little bit tricky. What I want to show you is that this piece right here, which is 90 degrees, and this piece here, which is 50, together, those add up to 140. And then this angle here is 40 degrees. So what you should be able to see is that this angle and this angle here are both consecutive angles. They are side by side. They don't skip from here to here. It skips or from here to there. They're side by side adjacent. Okay, not I guess I wouldn't say adjacent, consecutive in order. So that means then if they are consecutive, they're supposed to be supplementary. So does 140 plus 40, does that equal 180? That's the question. And the answer is yes, it does. So that means that this is a parallelogram. Okay? So on this one, if the directions say to tell whether the figure must be a parallelogram, on those, you're just going to have to be very careful because they're not only asking you to solve for the variable, but they're also asking you to determine if those measurements make the rest of the diagram true. So, and when you're all done, you're going to have to go back and plug the variable values in, and then see what kind of angles or what kind of sides it makes. And make sure that all your rules apply before you determine that. So in this particular example, we do have a parallelogram. Okay? Okay, hopefully that'll get you started on your homework this week.